To find the sum of finite geometric series, we have two what? We have two formula. The first one is A1, 1 minus r raised to power n, 1 minus r. And the second one is A1 minus an multiplied by r over 1 minus r. An in this case refer to what? Refer to the last term. The last what? The last term. So if the last term is given, so we'll use this formula to find what? To find the sum. But if the last term is not given, so we'll use the first what? The first rule. Let's take example. So also to find the sum of a geometric sequence, you need to know the first term, the common ratio, and n, which is the number of what? The number of terms you wanted to what? You wanted to add. And the first one, we wanted to find the sum of the first 6 terms. That means n equals what? N equals 6. We wanted to find S6. So that means n equals what? N equals 6. Of a geometric series, 8 plus 14 plus 24.5. That means A1 is given, which is 8. And the common ratio, it's easily to find the common ratio R by dividing any successive, any consecutive terms. So it will be 14 over what? 14 over 8. So the answer will be 7 over what? 7 over 4. So this is the common what ratio. The last term is not given here. So I'll substitute, I'll use the second what? I'll use the first formula to find what? To find the sum of the first 6 terms. So it will be S6 will be equals A1 bracket 1 minus R raised to power n over 1 minus what? Minus r. We'll substitute, we plug the letters by its number. So it will be A1, in this case, which is 8, 1 minus r, which is 7 over 4, or raised to power n, which raised to power 6, over 1 minus 7 over what? 7 over 4. So if one of you had a calculator, so please carry out this and give me the final answer.
295.7.
295
.7.
Okay, so this is what? This is the sum of the first what? Of the first 6 terms of what? Of this series. The second question, we wanted to find the sum of the first n terms, and remember, if you look carefully, n is not given here, of a geometric series with a1 equals 3, an in this case is what? Is this one, and r equals negative 2. An, as I mentioned, is referred to what? To the last term. The last what? The last term. So in if you look to this, the second formula, as I told you, if the last term is given, we will use what? We will use this formula. So an always refer to the last what? Refer to the last term. So a1 minus anr over 1 minus what? Minus r. So we will use the second formula. So a1 is 3, an is 768, and the common ratio is what? Negative what? Negative 2. So the formula will be Sn equals a1 minus anr over 1 minus r. So it will be a1 minus anr over 1 minus what? 1 minus r. We'll substitute. A1 is 3 minus A1, AN, which in this case 768, multiplied by r, which is -2, all over 1 minus negative what? -2, which is r. So one of you give me the answer.
513.
500 what? 530. So this is what? This is the sum of the geometric sequence which start by 3 and end by what? End by 768. So now I show you what is the difference between these two formula again. If the last term is given, so we can use the second one. If the last term is not given, so you can use what? You can use the first what? The first formula. Also, the sigma notation, we use it to what? We use the sigma notation to find what? To find the sum of number of terms of a sequence, either a geometric sequence or arithmetic sequence. And you know that we write what? We write the nth term or explicit formula in what? In the summation or sigma notation like this. So an explicit formula, this the base of the power, so the exponential part here, the exponential part is this part 5 n minus raised to n minus 1. So let me write it here. So 3 5 n minus 1. So this number is the first term a1 of the sequence of what? Of the sequence. So this sequence starts by what? 3. And the base of the exponential part, the base is what represents the common difference, which is what? Common difference, which is r. Okay, but remember, guys, from when we studied the arithmetic sequence and we used the sigma notation, a1 of the sum is not necessary to be the a1 for what? For the sequence, for the series, for the sequence. Because here we wanted to start adding, not from A1, we wanted to start adding terms starting from A2. That means because he asked you to start adding from n equals 2 to n equals what? 7. That means A1 of series will be A2. The first term of the series will be A2. So we wanted to add A2 plus A3 and so on, like what? To A7 like this. Okay, so we wanted to find the first term of the sequence, the series, not sequence. So A1 in this case it will be A2. So I'll substitute by n equals 2. So it will be 3, 5, n minus 1. So we'll substitute n by what? By 2. So it will be what? It will be 15. So this is the first term I'll start adding from. R, the common difference, as I told you, the base of what? Of the exponential part, which is 5. And n, the number of terms we wanted to add. So it will be 7 minus 2 plus what? Plus 1. So I'll subtract what? 7 minus 2. After that, I'll add what? I'll add 1. So it will be 7 minus 2, it will be 5 plus 1, 6. So I wanted to add 6 terms. 6 what? Terms. So S6 will be equals. I'll use what? I'll use the first formula. The first what? First formula. Because the last term is not what? Is not given. So it will be like this. A1 1 minus r raised to power n over 1 minus what? 1 minus r. We'll substitute. So it will be A1 of the series, not sequence, 15. So it will be 15. 1 minus r, r is what? R is 5, so it will be 5. Raised to power 6 over 1 minus what? Minus 5. So one of you give me the answer.
$58,590.
Again,
58,590.
58,990 like this.
590.
Okay, so that's it. So this is the sum what? The sum of the first 6 term of what? Of this sequence. So any question about this part? Any question? Okay, I want you to solve this question, please. So you have 1 minute to finish it. It will be the final answer on chatting. So let's check if it is possible to find the sum to infinity or not. By finding what? Finding the common ratio. So R equals negative 1.25 over 0.25. The answer is negative what? Negative 5. So can we find the sum to infinity? No, we can't, because the absolute value of R not less than 1. So the absolute value of negative 5 is 5. And 5 is not less than 1. 5 is greater than what? Greater than 5. So the condition not satisfied. So we can't find, no, we cannot find sum to what? The sum to infinity, because the common ratio is what? The absolute value of the common ratio is not less than 1. It's greater than what? Greater than 1. The next one, so this one for you. So solve it and send me the answer. I think this one, it's yeah, it's possible to find this the answer, the sum to infinity. So take your time, just 1 minute, 1 minute to send me what? The solution. Go ahead. So as you know, with the sigma notation, we write the explicit formula of the geometric sequence. And you know that this space represents what? Represents the common ratio. So this is R. And this number represents the first what? A1 of the sequence of what? Of sequence. So, and because we start by n equals 1, that means the first term of the sequence and the series are what? Are the same. That means A1 equals 120. Also, if you substitute by n equals 1 here, it will give you the same answer, because 1 minus 1 is 0. 0.8 power 0 is 1. 1 multiplied by 120 will be 120. And R, the common ratio is 0. What? 0.8. So the question now, if this one allowed me to add, to find the sum to infinity as he asked to find the sum from n equals 1 to what? To infinity. So the condition is satisfied, because the absolute value of R less than what? Less than 1. 0.8 is what? Less than 1. So yes, I can find what? I can find the sum to infinity. So S infinity will be equals A1 over 1 minus what? 1 minus R. So it will be A1, which is 120, over 1 minus 0. What? 0.8. So use your calculator to find the answer. It will be what? It will be 600. Yeah, 600.